Evening all. Evening all. Good evening all. Am I audible?
Yes.
Okay. I just Kiran Kaur will be hosting our today's session. I would like to welcome everyone to the third day of our one-week international virtual training workshop on research methodology and data analysis using SPSS software. I hope everyone is in good health and is having a wonderful time. It's time to welcome our today's panelist, Dr. Denekew. He is currently lecturer of statistics at Bahir University, Ethiopia. He has his bachelor degree in statistics in 2009 from Havasa University, his master degree in mathematical and statistical modeling in 2012 from HU from NORAD project, and his PhD degree in statistics in 2017 from Havasa University with a collaboration project from Norway, University of Oslo from Node project. He served as department head at Havasa University, Ethiopia before he joined Bahir University. He is currently served as an assistant professor in statistics in Bahir University. He has supervised more than 20 MSc students and currently co-supervises 2 PhD students. He has published research papers in different reputed journals. His area of research interests are infectious disease modeling, Bayesian hierarchical models in application of health data, epidemiological studies, modern Bayesian methods and computing for social sciences, projections using mortality data. And he also takes summer courses and has international conference presentations. Let's all welcome Dr. Denekew. Sir, please.
Good afternoon. Good morning. Good evening around the world. I'm so delighted to be here and a part of this workshop. This is, I'm going to share. Is it visible? Just share it. Is it visible?
Sir, it's not. Yes, sir, it's visible.
Mizan Tepe University, Cal University, and Matrix Thinking Foundation. SPSS.
Professor, your PPT is visible to us. Please start your talk.
Is it audible? Hello?
Yes.
Oh, thank you. Let me share it.
Yes, please share your PPT.
Is it okay now?
Yeah, it's fine. Fine, Professor.
Thank you, everybody. Thank you for everybody. I want to thank the institutions who made this.
Make it full
workshop
screen, doctor. Make it
Okay.
full screen.
Okay, yes, I can make it. Yes. Thank you, organizing institutions, Mizantep University, Akal University, and Matek Thinking Foundation. And I would also thank to the committee members, organizing committee members, and I will also thank to the participants. It is my pleasure to be part of this workshop, international workshop, and I have my talk is on getting started with SPSS software, and it is based on introduction and descriptive statistics. And as I've said before, it is organized by Mizantep University and Akal University in collaboration with Matek Thinking Foundation. My talk will on these three subtopics. It is on introduction to SPSS software, getting started with SPSS, and descriptive statistics. So we'll have first the background of the software, and then how to get started with this interesting software.
इंग्लिश एक पेन पेपर
And
दे
we
रही थी
will
मुझे बुक ऊपर है मैं तो बच्चे को थोड़ा फोन कर लेती हूँ नहीं
Hello?
नहीं मुझे
Hello?
रेफरेंस को बुक रहना था उसका किसी का तो पासवर्ड डाल लो
Okay, it's not me. It's not mine. Okay. Getting started with SPSS and making a descriptive statistics with SPSS. And the other inferential statistics will be for the next session. So let me start from
बेटा मुझे पेन भी मेरी बुक ऊपर है वो
introduction to
बुक के नाम के लिए
SPSS
लिख दे प्लीज
as
Please,
it is
please,
known, SPSS is a statistical package for social sciences. It is originally designed by social scientists and used by various kinds of researchers now for complex statistical analysis. So it was first created for statistical analysis of social science, but now it is used everywhere, I could say. So it's originally launched in 1968, before 50 years around, by SPSS Incorporation, but now it is acquired by IBM in 2019. So it is owned by IBM. Since then, it is called IBM SPSS software. So this software is used by market researchers, health researchers, survey companies, government entities, educational researchers, data miners, and many other researchers for analyzing statistical data. So this software has 4 important windows, and the main window is data editor window. This window has many features, the menus, which are going to be used for the statistical analysis, data management, editing, and entering data, variable declaration, and so on. So this is fundamental, and more of the tasks ended up here in data editor window. And the other is output viewer window. When you make an analysis, the output will appear in a separate window, which is called output viewer window. And then there is
Excuse
also
me,
a chart.
Denekew. Excuse
Yes.
me. Please share the screen. Your PPT is stable. We can see only the first title. So please share the entire screen. Reshare again.
Okay, let me. Okay, sorry.
Yeah.
Okay, I have to be here. Okay, stop sharing screen.
Select from the screen one. Yeah. When you share,
I have entire screen.
Yeah. Select the screen one. Okay.
Okay. Okay, let me start now.
Yeah, it's fine. It is fine.
Is it? It's fine.
Yes.
Okay. Okay.
Yeah, it is fine.
Sorry. So I have this. I have to start from here. I have these three outlines: introduction to SPSS, getting started with SPSS, and descriptive statistics. So I have said some introductory things about SPSS, and we'll start from producing the software. So this these four important windows are data editor windows, window, output viewer window, chart editor window, syntax editor window. So as I've said, data editor window is so important, and many of the tasks are here in data editor window. So we have two views. We'll see that data view and variable view, and we can enter values. We can declare variables, edit, delete, and so many data management techniques tools appear in this data editor window. And the statistical analysis are more in this data editor window. And when we make analysis by using some statistical technique, the output will appear in output viewer window. Then the other is chart editor window. This used to edit the charts. And the final one is syntax editor window. This is used to write our syntax if we need to have syntax-based analysis. So we have in this software we have two menu-driven analysis and syntax-based analysis. So we can use either of the two interchangeably, and they are not mutually exclusive. So there are menus and toolbars, and menus are so important and fundamental for our analysis, for our use, because this software is menu-based and syntax-based, but most of us used menu-based analysis. So there are so many menus, we'll see that, and toolbars, and these toolbars are used for quick and easy access to command tasks. And the common menus are file, edit, view, and analysis, graph, window, and help. And the toolbars provide, as I've said, quick and easy access to common tasks. So they are so important to have a quick implementation. And there are also a status bar, which says in editor, the SPSS process is ready, which means that it is ready to accept your instruction. Let's see four windows one by one, and we'll focus on the data editor window mainly, and we'll apply our data management using this data editor window. The data editor window provides a convenient spreadsheet-like method for creating and editing data file. And it has two, when you open this SPSS, it has automatically have two views, data view and variable view. The data view is displayed the actual value or defined value labels, and variable view displays the variable definitions of the declared variable. So there are so many definitions. We'll see that. And in data view, in data editor view, we have this application: entering data, editing data, finding cases, values, imputations, finding data and attribute values, obtaining descriptive statistic for selected variables can be done in editor value. This is the window. When you open the SPSS window, this is a default window that it appears when you open the SPSS. This is the data editor window, and this is an active view is the variable view, and there are names which says name, type, width, decimal, label, values, missing, columns, align, measure, and row. We'll see this one by one when you declare variables. And when you click here, it appears the data view like this. So the variable which we will write in the data view, for example, if I write one variable here, it appears in this column, in the first column. So the first column shows the first variable in the data view, and the first row shows the first variable in the variable view. So the menus, which we have to understand the functions of each menu in the data editor window, is fundamental in order to make use of this software. And file edits are familiar with us with like word sheets, so it's not that much difficult, because file is used to open existing file, to read, to close, and to save. So it's common with spreadsheet, other spreadsheets, and edit has similar functions that we know in like in a spreadsheet. The upcoming, when we come to the data menu, it is used to define variable, insert variables or cases, sort cases, merge files, split files, select cases, and use variable to wait cases. So it's important to data management tools. And the other and most important menu for data management is transform menu. This menu is used to easily create new variable, to recode variables to a new variable, to the same variable, and so many interesting functions as well. And this analysis has an ample of statistical methods inside, and this is the core idea, and this is used in many of the statistical applications. The other is graph, which is used to obtain high resolution plots, graphs, which can be edited in chart editor. As I've said, we have 4 windows. One is data editor window, and the other is, for example, chart editor window. So after having a chart, by using graph menu, we can edit our graph by using chart editor window. So this chart editor window makes our graph in high quality, and it can be customized as per our need and the required standards. So SPSS provides various commonly used high resolution statistical graphs. So you can go to graphs to make this. And the menus in the data editor windows, for the other menus in the data editor window are utilities, add-ons. These utilities are used to run and to display information on the content of SPSS, and this for the beginners is not so important for us. And add-ons are it used to provide many other statistical techniques that are sold separately. So if we want to add some packages, you can use these add-on menus and extend, or if one programmer have some packages, and in order to extend this by adding SPSS into SPSS, he can extend this by adding in add-on menus. And the other is direct marketing. This option is used to have, especially for market research, to make a cluster of, for example, customers in order to their purchase capacity, by their gender, by their locality. So it is used to classify or identify by using demographic, purchasing, and other characteristics that define various groups. So it's important for market research. And window used to move to an open. If you click on window, you can see different files which is opened in different SPSS files which is opened currently. So the tick mark is used to show you the active SPSS file. And help is as many softwares is important because everybody is not doesn't have sufficient knowledge about that software. So in order to develop his skill, he has to have a help menu, and he can get everything that he would like to know. So most of this slide is based on this help menu. So this is important to develop the skills about any statistical software, because it's not only about SPSS. It is used for many softwares in order to develop their skills. So please rely on help because there are so many things when you get into the job. There are so many obstacles that you might face. So please use help and get answers for that specific questions that you face. So this is the data editor window with a variable view. And as I've said, there are a variable has its own name, its own type, its own width, its own decimal points, its own level, value, missing values, columns, align, measure, and roll. So what is the name indicates here in this case? The name should be, it has its own properties when you write a name of a variable in SPSS. So to define a variable, it has not to be more than 60 characters. So we need to have a short name that can clearly or define the name of the variable, but we can write more than 64 variables. And we can start with special characters. And we can start with numbers. And we can't make a space between characters or words. So it has to be a single word with such properties. And a type is used to define the type of variables that you are going to use. It might be numeric, it might be comma, dots, scientific notation, date, dollar, custom currency, string, and restricted numbers. The most usually applied is numeric and string. Sometimes we can use dollar and scientific notation. So you can define based on, for example, if I insert here, for example, gender, and if I want to write gender as male for M for male and female for F, I can write gender without a space here, and the type is here a string because I will write the values F and M. If I record the gender as female 1 and male as 2, this can be recorded as a numeric in numeric. So it depends on the type of the variable that I am going to use. The other is the width. So all this in the one row, it is the property of one variable. Don't forget. So the width. This width is used to how many character values can hold. For example, if I am going to write a variable name, I have to write M for female and F for M for male and F for female. It is only one variable, one string. So I can, this width can be 1. The default is 8. So you can write 1 or you can leave the default. So when you click the data view, it becomes a bit shallow or a small column width, relative to others. And this decimal is not applicable if it is a string. it is only applicable if it's numeric in dollar and scientific notation. So the default is two decimal points. So you can increase and decrease based on your interest. So if you don't want to have a decimal point, you can make it 0. So if you want to have 4 decimal points, so you can make it 4. And the label is used to write the full and descriptive name of this short name of a variable. So you can describe fully as long as you want. I think you can write, I think, up to 2090, something like characters in order to describe these names, this short name. So everybody, so if one can open the data, and if you write this GN for gender, and you can describe GN for gender, this is gender for respondents. So you can understand the short name of GN is a gender of a variable in label. A values is a recording value. So it depends what you want. So you can categorize if you have a categorical variable by, for example, if I use gender has two categories, female and male. And if I categorize F for female and M for male, I can make a category for these values by using this and missing value. If you have a missing value, you can declare a missing value. For example, the default one is 999. So if you are sure of you don't have a value of 999, you can declare 999 as a missing value, but you have to be sure that 999 you will not have a 999 values in your observation or in your data. The column is used to widen up or shorten up the columns of the variable that appears in the data view. We'll see that as well. Alignment is a very simple. It is it right alignment? Is it center or is it left? So the values will appear in the center if you align in center. The value will appear in left if you align in the left side. Measure is used to. There are 4 types of measurement of variable measurement: nominal, ordinal, interval, and scale. So based on the type of variable, you can define your variable type by using measurement scale. But interval and ratio is categorized as scale, and in this measurement scale we have only 3 types: nominal, ordinal, and scale variables. So you can define those variables based on the property of the variables that you are going to plug in. So this is what I have said before. And for example, this is the data view window. In a data editor window, the data view section. So if I want to enter ID, it is numeric and its width is 4. So I only, and it is decimal. You don't want to have a decimal point. And what is ID in this case is labeled as employment code. So there is no value, it's not coded, and there is no missing value. The column for this is 8 sizes, and alignment has to be in the right, and it is a scale. And role, which I forget it in the previous section slide, is role is the default is input. Input is there are 3 types. Mainly we use 3 types of roles: inputs, target and both, and also there is none. Input is used as an independent variable. A target variable is used as an outcome variable. If we make it both, it can be used interchangeably for an independent variable or an outcome variable. But if you make it none, it doesn't use for an outcome variable, neither for independent variable. But don't forget that if whether you set it input or whether you set it outcome variable, it doesn't have any change on your analysis. For example, if I set it inputs and I used it as a response, it doesn't have effect on the results. What it used is it used as to clearly identify for third person if he or she opens the data immediately and he want to which one is the response and which one is the independent variable, he can understand easily based on this role. These are the independent variables, this is the response variable, and these are not important for that much important based on the role of the variables put there. So if we see gender, it is type is a string and it has a width of 3. So for example, in this case, I can't, for example, if I want to write female, all letters, I can't write that because I only can write in this variable only 3 characters. So it's defined to be up to 3 characters. So if anybody wants to write, for example, female, it stops there. It's not allowed to write a characters or letters greater than 3. So since it is a string, by default, this decimal point becomes 0. And the label is clear because the name is descriptive. So you don't want to have spent more time by writing so lengthy sentence. But you can write gender of the respondent, gender of a household, gender of a student, and so on based on a survey problem. So it's a gender. And the values are coded in this case F for female and M for male. So there is no missing value in this case, and there is no missing value. And the column in here, the column length in this case it is 8, it is 1. So when you click on the data view, this has a wider column, and this is a very narrow column, which is 1, and this is 8. So because why this appears, because we'll write kind of more string numbers, more numbers. For this gender, I will write only F and M. So it is enough to have 1 column length. And the alignment has to be left. And this is nominal because it's known that it's a string and the gender is considered as a name. It cannot be ordered, it cannot be quantified. So it's nominal and it is an input variable. So the default he took as a default and so on. If you go to birth date, it's date, and we'll see how define a date, and the width can be 10 and date of birth, and there is no values and there is no missing value, and the column length is 13, and it's wanted to be in the right, and it's a scale, and it's simple. So we'll see this one by one. And when I click, look, when I click data view, it appears like this. I declare the variables in the variable view like this, and when I click data view, it appears like this. So this row is a single subject observation. For example, a first guy responded as I have given this ID code, and his birthday is 27/12/1998. And for example, if I said 0 is for female, this is female respondent, and her age is 20, and so on, based on the coded items. So this is cases. The rows are the cases, and the columns are the variables. This is true for data view. And when you come to output viewer window, if I want to, for example, if I go to analyze and I make descriptive statistics, it appears in a separate window, which is called output viewer window, and this can be saved separately, and it can be opened separately. And we can export these values into words, or we can copy, we can edit variables, charts in this output window. So there is also one thing that we have to know is that when you make analysis by using analyze menu, whatever analysis we make, the syntax appears above the output. So this is the syntax that is used to produce this descriptive statistics. So the data set is dataset 1, and descriptives variable name is used to shall begin, and statistics is equals to mean, standard deviation, mean, and max. So if you copy this, and if you run this by copy in a syntax window, you will get the same result as this as it appears here. So the important thing that we must focus, we must use the syntax is if we have a lengthy menu-based analysis. So and if you do not want to repeat that lengthy menu-based analysis, we can copy that syntax and save that syntax and just run that syntax in order to have the same result for the next in the next time. Or if the guy or the researcher or the user is a beginner for this software, and if one shows him how to analyze a given statistical analysis, and if you don't want to have that procedure, he can copy the syntax and save that syntax, and he can analyze the same analysis by using that syntax. So it saves time, and it saves you to forget some lengthy procedures. But for advanced programmers, it can be used to write their own programs on this their own syntax, but it's not for beginners. But what my personal view, my advice is to use menu-based analysis and save that syntax for another analysis, for the next time analysis, if you don't want to remember that menu-based steps. And the other is chart editor window. The chart editor window is only displayed after a SPSS has been requested to produce a plot. So if I have a plot, and if I double click on the plot, the chart editor window will appear like this. The overhead floated window. It says here, if you see chart editor window, can you see this one? this is the chart editor window, and you can edit by using these toolbars and menus. So you have many interesting functions in order to edit or customize the variables, and it's so important to make your variables so interesting and publishable graphs, to produce publishable graphs. And this is syntax editor window. And this syntax editor window is, as I've said, used to run by using these programs. So you can write, if you remember, for example, dataset, activate, that you write a data name here. And if you want to plot a graph, you can say graph, line, simple, country by salary, and so on, right? So this produce a line graph. If you run, this one is the run function. So you can run this syntax, and you'll have the same graph that you made it using the graph menu-based analysis. So the syntax is the programming language that is used in SPSS, and it is unique, and it allows to write commands that run a specific procedure rather than using graphical user interface or menu-based steps. And this menu-based and syntax-based methods of can be used interchangeably, and they are not mutually exclusive. And you can use both methods, and they will have the same results. In the same results by using syntax-based and menu-based. So these are the menus. And these menus are, for example, file. It's similar as Word spreadsheet. Edit is similar as you can create new SPSS window. You can open SPSS or other data types. You can open syntax. You can open outputs, and so many other things. And you can rename, and you can save as. You can save. You can close. You can find recently used data. And in editing, though, it's as usual, as similar as Word sheets, spreadsheets. And view, in this case, you can customize some features. For example, if you click variables, it will appear the all names. Let me show you. Let me back all these names. So if I want to, for example, if I want to take out a line because it's not so important for me, if I believe it's not so important for me now in my data, and I want to take out this from my window, I can take out, and if I want to as well as take out role, I can click variable here, and there are procedures, and you can untick role and align, and it will appear other variables rather than align and role. And data management starts from the data menu. And it's so important for our data management in SPSS. So you can sort cases, sort variables, transport, merge variables, split files, and so many other interesting instructions in data menu. And I would say the most important data management tool is transform. In this transform menu, there are so many so many applications in transform. You can compute variables, you can decode variables into the same variable, into different variables, and it allows you to make different data management transformation systems by using this transform menu in SPSS menu. So it's data, and the menu data and the menu transform are, I would say, mostly responsible for data management. And this is so important to know, because when you have a big data, you need to make some data management systems, and you need to have some know-how about your data, and it uses to have you to apply some statistical transformations, recording, computing variables by using these two menus. And this analyze is, I'd say, the whole game starts here. And it has an ample of statistical application, and all of, I would say, statistical application except graph appears here. So all models, statistical models, hundreds, maybe thousands of application appears here. So after transforming, or after managing your data, after declaring your data, after field your observation, after transforming, or after managing your data, you are going to apply some statistical application by using this software. And this statistical application is found in analyze. So you can have descriptive statistics, compare means, general linear models, correlations, regressions, Poisson regression, and so many applications. So many applications are here. And the other is graph. So this graph we usually use after graph legendary legacy diagrams, and we will have these choices, and we'll see some of the graphs that can be used in this graph technique. And there is a window. In this window, you'll see the current opened data in SPSS. For example, this untitled SPSS is the only data appears in this case. And the other is help. You can write a topics that you want to apply, or you can see the tutorial, or you can search statistics course. So this is so important to develop your skill. Nobody is perfect in any of the software, because the software usually developed by teams. So it is a work of a team. So a single guy is not perfect in that software. So it is usually advisable to rely on helps when you want to develop your skills. So let's get started with SPSS. And this will start with data entry and then data management. Let's start from data entry. And I will share my software. For example, you can write, as I said, since 2009, it is called IBM SPSS Statistics. Before it was called SPSS. After it acquired by IBM, it is called IBM SPSS Statistics. And you can, after you install the software, you can search from your browser IBM SPSS software. My version is 23. You may have 26, 25, 24, 18, 20, whatever. But it has its own improvement and additional utilities or features. But for us, for beginners, most of them are similar. So I can click here and it will open automatically. But for my case, I have an opened data, and I will enter the data, some selected. So this is the open data, and I will have I want to have a new data script window, data editor window. This is the data editor window, the data editor window. So this is the variable view, and this is the data view. When I click here, it shows a variable view. When I click here, this is a data view. Let me start to declare variables. If I want to declare, for example, I will declare some 3-4 variables by examples. Let me declare first date. I will write date. I can't make a space. If you can't make a space, it will say you wrong. Variable names contain an illegal character because I tried to make a space. Is it visible?
Yes.
Mahar. It's, and I want to and I can't start with a number. I can't start with a special character. For example, if you want to start with, it's not possible to start with. So let me write date without a space, a single number, a single word, and let me define the type of variable that what the date is. And unfortunately, I have specific type for date, which is date. And I want to define what type of date I want. Is it day, month, year, or is it day, month? So I want to have like this: day, dd, yy. In this case, it will appear. I can write 2 digits day and 2 digits month and 2 digits year. So it's based on your interest, you can define this. You can define either this one and either this one. For now, let me define this one. Yes, defined. Now the width is number of characters that, and this it is automatically, the decimal automatically 0 because it's date, it's not numeric. So the level, I can write the full length, the full description of this name. What is the full description of this name? I can write, for example, date of birth of the respondent. You can make a space. You can so if anybody sees this data, he can understand what this data stands for. So date of birth of the respondent. And value, I don't have a value. I've just defined a date. And if I don't have a missing value, I can pass this one. And I can increase the column. For example, let me make it 20. And I will show you what appears. And what is the alignment of this in the data view? This variable, is it center, right, or left? Let me make it center. And let me make it a scale. And is it an output variable? Is it an input variable, target variable, both or none, or partition? I will put it as a default. Let me define the second variable. Let me gender. And I can define these variables into 2 ways. One, I can define this as a string. The second option is I can define this as a numeric. Let me start from a string. So the characters are 8. I can't pass. I can't enter more than 8 variables. For example, in this case, I only have female and male. Female has only 6 characters, so I can make it 6. if you, for example, if you by mistake make it 3, you can try it, for example, if you want to write the full length of female, it will appear, it will be wrong. So now in this case, I will make it 1. I'll show you why 1, because I will define the variables. This descripts the label is categories, gender, which are female and male, as female, and I would say add, and M for male, look, let me come to this. Can you see this? This is a bit wider column, and this is a bit narrow column, because I make this column width 20, and this I take as a default. So if I want to, because it is only one character, because I will write F or M, so I can make it 1. So I will have such column lengths. So not have a missing value, and the alignment is left, and it's automatically named because I define the type of the variable as a string, and it is nominal. So I can have another option, gender. I can write the same name in my single SPSS file. So I have to name a different name, gender 2, and I can write this as a name, a numeric, and I want to make this 0 because I don't want to have a decimal point, and I can have the same label. And when I come to value descriptions, I can write 1 for female and 2 for male. So either of the two, anyone can use either of the two. He can use F and M for female and male, and either he can use 1 and 2 for female and male respectively. So it depends on his interest. He can use, but in this case it is a string and it is a numeric, and in this case it's a scale, and I can make this right. Make it right, and I took it as a default. You can decrease because it is 1 and 2. This can be a bit wider. So let me make it a bit, if I show you. Okay. Now let me define another variable. For example, age, which is continuous, right? Age, and it is numeric, and I don't want to have a decimal point, and you can write the label age of the respondents, and I don't want to have a value because it's a continuous, and this is a scale. Now I can, if I for example, if I collect a survey and the variable age is categorized, for example, if I categorized some groups below 15 up to 30, 30 up to 45, 45 up to 60, and above 60, I need to have a categorical variable, and age can be categorized. So this can be added. For example, 1 is labeled as below 15 years old. And 2 goes to between 16 and 30. 3 between 31 and 45. 4 between 46 and 60, and 5 is above 16. So I can categorize. Sorry, I have to add this one. I can categorize the continuous variable based on the interest of the research. So if it is numeric, you can use as it is. And if it is a categorical variable, you can use as sorry, I have to be faster. And salary. Let me salary. I have to pass this one, and I can have one more variable, educational. Sorry, education. Education. This is numeric, and you can describe as you want by using this space. And I want to have 3 variables. For example, 1 stands for a primary school, and 2, for example, above primary. And yes, so this is how to define or declare variables. After declaring a variable, we can go to data view, and we'll have these variables 1, 2, 3, 4, 5, 6. So let me keep the default values. For example, I have to make this 8. Yes, make it. Yes, if you take it as a default, it appears like this. So if I want to write, for example, the guy for the first respondent, this is the first respondent, the full information of the first respondent. So if his or her birth date is in the 10th of April 01 in 1998, it will appear like this. So 15th of sorry, it is 1. Yes, it is 15th of April 1982. Wait, 98. Yes, 50th of April 1998, and her gender, the gender is female. And for example, if I want to have 1 and 2, it is 1, and her age is, for example, 98. Can you please remember? 23, I think. 23, and this is in 2, category 2. And if her question is above secondary, it can be 2. So this is the full information of one respondent, and this is the whole information of one variable, and this is the whole information of one variable. So in data view, the row is a case for a given information, and the column is the variable. And let me go to data management. In data management, as I've said, if you go to file, there are a lot of options, and this is similar with spreadsheet, and edit and file are similar. But in view, if you go to in view menu, you can have these variables. If you click this one, okay, what's this? What's this? Okay. Let me go to view variables. Okay. Oh, sorry. If you click, sorry. If you click customize variable view, you will have this one. And I don't want to have the role. No, sorry. The align, because it's not so important for me for the, and for example, role, because all are input variable and alignment is where I shall put the values. So if I want to have only this without role and alignment, if I click OK, all the two will disappear. So there is no role and there is no alignment. So you can choose whatever you want in this case. So let me make it back. Now, this data and transform is so important in data management, as I've said. And let me use employee data. Please open employee data for your purpose if you have a laptop. So for example, in file, you can open Excel files. For example, let me sorry, international file, sample data, and I have to change this one, Excel, and I can import this. If you want to import and this read variable names from the first row. So in Excel, the first row, if you put the variable name in Excel in the first row, it is asked you to read variable names from the first row. So if it's not, you can untick this one, and I will click OK. So it will appear a variable which is this is the variable. This is the variable which I imported from the Excel. So you can import the data from Excel as well. So let me go to data, and let me show you some fantastic selected applications in data. Let me make some select cases, sort cases, sort variables, merge files. Let me first select cases. Please open employee data, and let me show you how to open the employee data. Follow me. Open file. Let me write it. Let me file. Open data, and I will go to local disk C, because the programs are there, because I want to open employee data which is found in the software. So I'll file program files. From program files, there is the name of the software, IBM. And from IBM, it is SPSS software, and it is statistics. It is the version 23, and I want to have samples from this. And it is a version. It is language is English. You can change into Russia, into China, into Spanish. So now currently it is in English, and I want to open. There are, for example, there are many files in this case. So I want to have employee data. This one. So I just open the file employee data, which is a built-in or a default data when I install my software, all this data can be found in the software. So you can use for teaching purpose. So I will use the employee data. Just click open. I will say it's open because I'll not say it's open because I have it already. So if you open it, follow me. Let me do some data management techniques. Let's start from data. Let me select. If you have thousands or millions of observations, sample size, and if you want to select some features from that variables, you can go to select. And for example, I have different variables, and I want to use minority classification, and use if condition, and I want to insert minority. Minority in this case has two classifications, yes or no, minor or minority or no. So I will say I will use select only the minority groups. So minority is equals to 1 indicates it will select only the minority groups. So let me say it okay. And let me go to employee data and data view. And if you click this one, can you see this one? This value labels interchangeably show you the values. So for example, if you see job category, manager, clerical, so you can interchangeably see the values and the value labels. So these are not selected. If you see the slashed values, these are not selected. So you can exclude these unselected values, and you can make analysis based on the selected values. And these are the only selected values. And from the data, if you want to split your file, you can split the file. For example, if you want to split the data into groups by gender, you can use this, and all analysis will appear separately. For example, in this case, it has age and, for example, female and male. So the analysis will appear. If you want to have a descriptive statistics, one table for male and one table for female. So you can split a file by using this gender or minority classification and other things. So let me make it select cases, and all cases I'll take it back to the original. So it's back to the original. Look, yes, it's the original. And if you go to sort cases, if you want to sort cases, what type of variable you want to sort? For example, the current salary, I want to see the minimum in increasing order, the minimum salary. If you want to sort the variables from by using ascending or descending, you can use this, and you can save file with sorted data. If you want to save with the sorted data, you can click this one. But I don't want to save this file, and I want to keep the original, so I don't want to click in this code. So if you see the sorted data, let me see. What is, yes, look, the minimum salary is 15,750,000, and the maximum, if you go to the maximum, is 135,000. and this is for manager, and this is for clerical. And you can sort variables, and it's not important for in this case, and you can merge files as well. Add cases, for example, if you insert or fill observations or values with a separate laptop, and if you want to merge values in the bottom of your variable, you can merge files. Or if you have different variables and you want to merge into the right side, you can merge variables. So there are two types in merge files. Add cases, add files, add variables. In add cases, you are going to add observations in the bottom. In add variables, you are going to add variables in the right side. And let me go to the transform, because time is running. And I will show you three important things here. In transform, you can make three things. One, you can compute variable. For example, if you want to compute the difference between the current variable, what's the target variable? I want to say difference, salary difference. And what type of difference you need? The current salary minus is here, right? The beginning salary. And I want to divide this by 2. By 2. Yes. So the sal difference will appear in my new as a new variable, and this new variable comes by computing different variables, existing variables. The current salary minus the beginning salary divided by 2. So if you click it OK, it will appear in my look. This is the difference. This is the difference. The difference of, look, the difference of 15,750 and 10,220 divided by 2. And if you want to have another computation by using different variables, you can use some techniques, these techniques. And another interesting feature for this is recording to same variable or recording to different variables. For example, let me show you. I have educational level, and the labels are, look, let me show you. Okay, this is the labels. It has 8 is 8, 12, 14, 15, 16, and so on, up to 21. And I want to record this as 1 and 2. One is a primary school, which is 12 and below, and the other is secondary and above, which is 14, 15, 16, and up to 20, up to 21. So I want to record this. Let me show you. Record into different variables. I have educational level and 2, because I have edu here, educational level, which is edu, and you can write the full level, educational level of respondents, or I would say recorded educational level. So if you say change it, this variable, this label will appear there, and and I want to record by you clicking old and new values. So the old values, for example, I want to categorize 1 and 2. 1 is those 8 and 12, and 12 are and the others are 2. So let me, 1 is sorry, old values, 8 is 1, add 12 is 1, add, and I have only two categories. I can say all other values are 2. So I will record 1 and 2, and 1 is only 8 and 12, and 2 is 13, 14, 15, 16, 17, 19, 20, and 21. So all other values can be. Otherwise, you can make this by typing each one. But okay, let me say add. Yes. Else 2. If it is 1, it will record 1. If it is 8, it will be recorded as 1, and if it is 2, it will be recorded 1, and the others are recorded into 2. And let me say it okay, and let me check. And there is 2 different values: SAL difference and education 2. And the label is here, and I want to have values. Value 1 is primary education, and value 2 is secondary and above education. Education. Yes, and this is on continents. Okay, so if you see here, I will have 1, 1, 1, 1, 1, 1. Look, and 2. What is 2? Let me check. 2. 2. If yes, 2 is 15, and this is 12. It is 1, and this has to be 2. Yes, so it is coded 1 and 2. So you can make this transform, and you can also record into the same variables. So if you want to record months is hired, and by using recording system, you can delete the original variable, and it will be it will have the new variable. So you can make these things as well. Now let's come to analysis. Let's come to analysis. Analysis. Let me make a descriptive statistics, and I want to make a descriptive statistics for beginning salary, and where is and the current salary. By clicking option, I can which description can be visible. So you can choose which description can be shown in your statistical descriptive analysis. So if I say it okay, look, I click it here, analyze descriptive statistics and descriptives. So this is the output, and this is sorry, and this is the syntax as well. If you see descriptive variables, salary, sal begin, and statistic. This is sorry, the syntax as well, and this is the descriptive statistic. The number of observation in this data is 474, and the range is 119,250, and the minimum is 15. We could see this by when we arrange the variables, 15,750, and the maximum is 135,000, and so on. And the kurtosis, the skewness, and so many variables that we would like to have. And if you want to, for example, if you want to see some selected values, I don't want to have this. Okay, variance, mean, minimum, and maximum, and I don't want to this. So it kind of yes, this is some selected values, right? So the current salary, you have an observation 474. The minimum is this one, and the maximum for this data is, and this is the salary. The salary. So you could see the ranges or the differences between the employees in that company. The minimum is 15,000, and the maximum is 135,000, and the mean is 34,000, and the deviation, the standard deviation is $15,000. And let me, we're running out of time, and I have to show you some graphs. Dialog box, you can go to graph and make dialog box, and let me first make a pie chart, and summary groups. And you can, for example, let me educational level, and let me make gender. Where is gender? And let me have this. Yes, here it is. This is a pie chart for educational level by grouping male and female. So you can edit these plots by double clicking. If you double click, I will have chart editor. As I've said you before, this is another part of another window in SPSS. So you can edit this by clicking this one, right? If you want to have, for example, a percentage, click here. If you want to appear this one, let me see, and what happens? Number formats, panels, yes. Let me apply this one, and what will happen? Yes, if you want to have what this and all these are female, of course, and the red one is 0.46%, and this is 15%, and so on. So you would like to have, if you would like to have these descriptives, you can make these things, and you can have other acts of the graph. And if you will, okay, let me make it pack. And if you would like to make another graph, go to graph, legacy dialogues, then box plot, and let me make a simple box block, and the current salary, yes, with employment category. Let me make this. Look, this is a box plot for current salary using employment category. This employment category, there are clerical, custodial, which is the guards. This is the manager, and this is the typists. And you can see and you can visualize which took the highest salary in that company. And the managers are the beneficiaries, and the median is, you can see, let me see the values. Let me see the current salary. No. Yes, if this is the median, and this is the third quartile, and this is the first quartile. As you all know, the median shows us it is the middle value, and it divides our data into two equal parts. And 50% of the observation below this median value. And if it is symmetric data, the median, the mode, and the mean are the same. And this is the minimum value, and this is the maximum value, and these are the outliers. And this is Q3, which is third quartile, and it tells us 75% of the observation are below this value, or in our case, 75% of the salary is below this value, and you can see this, the median value for clerical is much less than for manager, and custodial is a bit larger than clerical, and it is much smaller than the manager. So there are few numbers for managers, and there are large numbers are in okay, and we can edit this as well, and you can compare these values as well by making quartiles, means, and so on. And there are so many applications of statistics in analyze menu, and we will see these applications for the coming. For example, comparing means independent sample t-test, one sample t-test, pair sample t-test. One way ANOVA will be discussed for the upcoming sessions. For now, I have to stop here. Thank you, everybody.
Participant, if you have any kind of question, please feel free ask from the speaker. You can do unmute your mic and then you can ask the question.
Thank you so much, Mr. Denekew. Professor Denekew, from participants, do you have any queries? Please ask our speaker. Dear participants, if you have any type of query regarding today's session, please ask our speaker, Professor Denekew Bitew. Please proceed. Is there any query from audience side? Dr. Meherchand, I think the participants understood very well. So I think they don't have any queries. So can we proceed?
Yes, ma'am. There is one question in the chat box.
Okay.
Question is how we can merge data.
Okay.
Yeah. Question in the chat box is how we can merge a data.
Okay. How can we merge data? Okay. Let me see. Okay. Can I proceed? Yes. Merging data can be found in the data menu, and look, this is found in merge file. So merging data has two types: merging, adding cases, in the bottom of the observation or adding variables in the right part of our variables. For example, if you see these variables, this employee data, I have a couple of variables up to education 2. So if I want to merge additional variables, I can merge variables. I will show you. Or if I want to merge files or observations, in this I can append the values in this case. So I have to choose merge or add values if I want to add observations. Otherwise, if I want to add variables which have different variables and its own observation, I can merge files. Let me go to merge variable, add variables, and I have to click here, add external SPSS statistics file, browse, and let me click this because it has another variable and I want to merge this one. And look, the added variables are, these all are the existing variables. This star sign shows us the existing variables, and these two variables are the newly added variables. So after checking which are newly added variables, I can click OK. Now I will have two variables. Look, these variables, number of children and reading habits. So if I have a data file which has different variable name and different observation, I can merge files in this way. But if I want to merge observations with the same variable names, I can use a different way. For example, if you go to merge files, add values, an external click an external SPSS statistic data, open, and data to be merged. I have a data because I have a data, and I just click open. Before it has, I have 474 observations, and I am appending additional observations to the existing data. And there are new unpaired variables. It says education 2, number of children, reading habit, and cell difference are unpaired variables. So I can keep this one because it has the original variable has the original data has these variables, extra variables, and the others are paired. All these are paired. So let me make it OK, and let me see the number of observations. Look, now the number of observation has to be greater than 474. These are the original observations up to this, and I have added another observations. So you could add based on the interest or the data type. If it is an observation which is appended on the bottom, you can add cases. If it is a new variable with different variable name and different observation, you can add into the right of the file, the variable names. This is, if I get you this is the response. Thank you.
There is one more question from Bitew Bekele. Question is, why we use numeric similarity for gender and age?
we use numeric?
Yeah, numeric similarity for gender and age.
Okay, if I understood you, let me go to. Look, I have added. Where is this? We have yes, is this one, right? Look, I think this is the question. The thing is, why when you make it numeric, the variables that you are going to fill in the data view, I will use 1, 2, and 3, 4, 5. So this is the number that I'm going to fill in the data view. So if you go to data view, H2 has to be feeded either 1, either 2, or 3. And these are numeric values. But when you apply in, for example, if I use this as an independent variable in a regression analysis, I can make it as a categorical, and there is an option in a regression analysis to make this as a categorical and categorical variable. So we make it numeric because the value labels are numeric. So don't forget, this is for the value labels, not the exact future of the variable. What is the value labels? These are the value labels. This one. The value label is numeric. So due to that, I just make the type of variable is a numeric. But if you, for example, gender is numeric, why I just numeric for this gender? Why just make it numeric? I just coded female as 1, and this is numeric. This is numeric. If I code this as F and M, this is not numeric. This is a string. So this is based on the value label, not the future of or the characteristics of the variable. So when you use in regression analysis or any other statistical analysis, there is an option to declare such variables in upon your request. Thank you. Thank you.
There is another question in chat box. The question is, after we key in data in SPSS, is it possible to clean it? If yes, how is it done?
What did you say? Sorry. Let me check. Let me check. I couldn't see. Can you please repeat it? This question?
Yeah, sure. After we key in data in SPSS, is it possible to clean it? If yes, how?
Okay, if I understood you very well. Let me see the chats. Okay, after we key in data in SPSS, is it possible to clean it? If yes, how? I don't understand what is
Yes, the question is not very clear.
If I understood you, let me try to answer. I've just insert these variables. Okay, look, I have these variables, and if I want to delete or if I want to clear minority classification, I can right click on the variable. First, you have to click variable view, then click the variable name that you want to delete or clean the data. Then you can clear the variables that you want to clear, and you can clear all the variables. For example, I just click this and it's cleaned up. Or you can go to data view. You can click like this, the column, and you can clear the variables. And also you can insert the variables as well. You can make a descriptive statistics as well in shortcut. So I think if I understood you, it is possible to delete or clear the variables, all variables that you would like to clear. If I understood you very well, this is my just replace it. Okay. Is that clear? I've just finished.
Thank you. Thank you, Professor Denekew, for your extremely excellent presentation. Now I would like to invite Dr. Meherchand, MTTF President, to present the certificate to our today's speaker. Meher sir, Dr. Meherchand, please. Dr. Meherchand, you are requested to present the certificate. Dr. Meherchand, are you there?
He's muted. He's muted. Okay.
Yes. Please accept the certificate, sir.
Thank you so much. Thank you. Thank you. It is my pleasure to be a part of this, and I would like to thank all organizing institutions, organizing committee, and the participants as well. So I'm so proud to be here and to be part of it. Thank you so much, everyone.
Dr. Denekew Bitew, please accept our sincere appreciation for the outstanding presentation you gave on today's topic, getting started with SPSS, Introduction and Descriptive Statistics. You described very elaborately the basic of SPSS software, how to enter data and how to manage data efficiently, and it is also explained by you in your presentation that how to present graphs, analyze and transform data, etc. So hope all the participants will be very much beneficial for this session, and hope all the participants will are very much appreciated you too for your great performance today. It's an honor to share our space with you for us, no matter this is a virtual mode of presentation, and so virtual mode we are meeting, but still we are honored. We hope in future too we will maintain this collaboration so that we can continue our journey, the journey of sharing the knowledge. So lastly, an important announcement for the participants. So all the participants, you are requested to fill the feedback form of today's and yesterday's too. Those who filled yesterday, ignore, and otherwise fill both the feedback form. That is very much important for us. So with this note, I would like to end this today's session. So tomorrow